In February 2019, a research vessel was behaving strangely. It would sail for a while, then stop, lower something into the water, and move on again. The object being dumped was bound with rope and weighted so it would sink straight to the bottom. This was no ordinary cargo. It was part of a deep-sea experiment. Whale falls are among the rarest natural events on Earth. When a whale dies and sinks to the abyss, its massive body becomes a temporary oasis of food in an otherwise barren environment. Scientists studying these ecosystems have long relied on chance encounters, hunting for them with remotely operated vehicles in the darkness thousands of meters down. The odds are roughly those of a blind cat stumbling upon a dead mouse. So researchers began creating artificial versions. They started with whales, then expanded the idea. Shark falls, seal falls, sea lion falls, even cow bones, turkey carcasses, and pieces of wood were sunk to the seafloor. The practice grew increasingly widespread. In places where American alligators are abundant, so common that locals joke they outnumber squirrels and occasionally turn up on golf courses, scientists found a new opportunity. Because alligators sometimes attack people, regulations allow certain individuals to be euthanized. One researcher, Professor McLean, used these carcasses to create the first intentional alligator falls. The experiment raised interesting questions. Alligator skin is thick and armored, and the animals were being placed in an environment where large scavengers are scarce. Would the feast attract visitors more slowly than a whale fall? Who would be the first to breach that tough hide? Sharks, with their serrated teeth and death roll behavior, seemed the obvious candidates. Reality proved different. Within 24 hours of the alligator reaching the bottom, the first guests arrived. They were neither sharks nor hagfish. Instead, a group of large, segmented, armored crustaceans, roughly the size of basketballs, appeared. These were giant isopods, Bathynomus giganteus, mysterious deep-sea scavengers. Their arrival so quickly suggested an extremely sensitive sense of smell. Despite their somewhat clumsy appearance on land, they are surprisingly agile swimmers. Using powerful mouth parts, they efficiently tore open the alligator's tough skin, exposed the ribs, and even crawled inside the carcass to feed from within. Their feeding was so thorough that later arrivals may have found little left. Giant isopods belong to the same broad group of crustaceans as shrimp and crabs. Their closest familiar relatives are the small terrestrial woodlice, also called pillbugs or sowbugs, and the parasitic tongue-eating isopods that replace the tongues of certain fish. While those relatives measure only a few centimeters, deep-sea giant isopods can exceed half a meter in length. This size difference is an example of deep-sea gigantism. Many animals living in the abyss grow far larger than their shallow water relatives. In an environment where food is scarce and unpredictable, a large body allows an animal to store more energy and survive long periods between meals. The isopods that stripped the alligator were operating on exactly this principle. Footage from Shark Week in 2015 showed a similar scene. Two spiny dogfish were trapped in a deep-sea cage. One suddenly began thrashing violently. A giant isopod had clamped onto its face and refused to let go. In the next shot, the shark lay motionless on the seafloor while a group of isopods fed on it. The same efficient scavenging behavior observed with the alligator. Despite their formidable reputation in the wild, giant isopods kept in aquariums are generally uninterested in people. One famous individual, brought into captivity in 2007, refused food for 1,868 consecutive days, more than 5 years, before dying. Scientists later dissected it to determine whether illness had caused the prolonged fast. The exact reason remains unclear. Several anatomical features make these animals well adapted to their environment. Females produce some of the largest eggs of any invertebrate, exceeding 10 millimeters in diameter. Once pregnant, a female must limit heavy feeding to avoid crushing the eggs. Their abdominal appendages function both as efficient swimming paddles and as gills. Their large, triangular eyes contain reflective layers similar to those in a cat's eyes, allowing them to capture and reflect the faint light of the deep sea and giving them a glowing appearance. In Japan, giant isopods have become popular cultural icons. Their distinctive, somewhat endearing or unsettling faces appear on merchandise, and high-quality plush toys capture their armored details. They are also eaten in some places. The meat is said to resemble shrimp and can rival sea cucumber in texture and appeal. True giant isopods of the largest species are primarily imported from Central America. Smaller but closely related species occur in Asian waters. Regardless of origin, these animals play an important ecological role as scavengers, helping to recycle nutrients that reach the deep sea floor. In short, the giant isopod is a highly efficient deep-sea cleaner with a surprising combination of toughness, patience, and unexpected charm. Rather than focusing only on how they might taste, it is worth appreciating the remarkable adaptations that allow them to thrive in one of Earth's most extreme environments.